The last skill in P9 is to put our knowledge about sets and linear inequalities together to determine solution sets of some problems where you're given inequalities with other conditions. So first, I want to review what the absolute value of x means. So I believe we talked about this in P7, but remember that the absolute value of x means that the distance of x from 0 is something. So in this case, we're saying that the distance that x is from 0 is 4. So if I look on a number line, here's 0. I can say, okay, x is out 4 units in the positive direction. And now remember, distance is a non-negative quantity. So it means that you can either go 4 to the right, and you'd end at positive 4. And I shouldn't actually say that this is 4. I should say this is x. Um, or I can say the distance that x is from 0 in the other direction is also 4, but that would land me at negative 4. So when you have an absolute value of x, that means that you have two solutions. Okay. Now let's look at this other problem here. So it says determine the solution set for p if absolute value of p is equal to 2 or 2 minus 3p is greater than or equal to 6 plus p. Now, this we just talked about, so we're all set up to handle that. This we saw how to do in the last video. This is essentially just solving for p with a linear inequality, and so we know how to write that solution set. But now this or, remember that in set notation, when we see the word or, we want to think union. Okay, so if I have absolute value of p is equal to 2, that means that p is going to equal plus and minus 2. Okay, and then, so I can put that on a number line. So let's see, here's negative 2, here is positive 2, and then if I go ahead and solve this, 2 minus 3p, so let's see, I'm going to add 3p. Oh, wait, I don't like it on that side. I'm going to move this p over, so subtract p, and from both sides. And let's see, then I'm going to also, let's see, so p's will be on this side, subtract 2, and come up here, subtract 2, and so I end up with negative 4p is greater than or equal to, let's see, 4. Okay, and I need a little bit more room here. And so I go ahead and solve this, and I get p is less than or equal to negative 1. Okay, so this, remember I divided by negative 4, so I need to switch the direction of the inequality. So I put negative 1 on my number line. Okay, so now I need to figure out if I have dots or like open circles or closed circles, and also if I have things going in either direction. So if I have plus and minus 2, those are actual dots. So I have a dot here, and let's see, a dot at negative 2. Okay, and now I want to work with this one. So this is at negative 1. And then this says less than or equal to, so I need to go to the right. And that should go through the dot. Okay, so now I need to represent this as a solution set. So again, since I have a closed dot and a line, okay, that just means that it is in my solution set. So I can start by writing the solution set for p is, okay, and now I need to express this in interval notation, so that starts at negative infinity and goes until negative 1, and then I have a bracket because of closed circle. Oh, let's try that again. Okay, and then I union this because this isn't all the numbers that I have in my solution. I actually have this one as well. Now to represent that, I actually need to do a squiggle, a curly brace, okay, because this is its own set. So I'm unioning, I'm adding the two sets together. So union 2, and then I need this in curly braces, and I'm done. Okay? So again, make sure that with OR, you're putting everything together. So all of this stuff is in the solution set. If it's AND, we'll see an example like that. It'll be a different case. Okay, a couple more examples. Now, in this example, same sort of thing. So I see OR, I think union. So whatever solution sets I get from both of these, I need to put it all in one solution, and all in one solution set. Okay, so this time I'm not going to do it graphically though. I'm just going to do it analytically. So I'm just going to solve. So 3 minus 2k plus 3 minus the quantity 2k plus 1. So I go ahead and distribute that negative sign to both terms. And so it's 3 minus 2k minus 1 is equal to 0. Go ahead and solve this. So 2k is going to equal 2. Okay, and then I solve and I get 1 is equal to k. Okay, and now I have to think, okay, well, this means this says that k is all numbers greater than or equal to 3, and this is k is equal to 1. Okay, 1 is not in that set, and if it helps you, you can draw a little line. I'm going to avoid doing that in this example. And so I would remember, since I have OR, that means that both of this stuff, or both these things, are in the condition for the solution. So I would say the solution, and I'm abbreviating solution, the solution set for k is, and now I have this as a single point, and then this as the interval. So I would say curly brace 1, curly brace, union, and then I would start at 3, go to infinity, and I have a parentheses here, and I should have a bracket here. Now if you flip the order, that is totally fine, doesn't matter. Okay, so that one was a little bit easier than the last example, but I did it without making a graph, just to demonstrate that you can. I think that it's easier to make a number line and put it all on there, and this next example will do just that. Okay, so determine the solution set for m if that and m is no more than 2. Okay, so now we give you a different conjunction, and we give you a condition in words. Okay, so if I go ahead and kind of parse this, okay, this I know how to solve. This is a linear equation. Okay, so I should get m is equal to something. And, okay, if I see and, that means intersect. So now I need to look for everything that is common between these two conditions. And expressing this in symbols, m, okay, if m is no more than 2, how does m compare to 2? If it's no more than, it has to be less than or equal to. Okay, no more than. It can be equal, but it has to be definitely less than that. Okay, so now I go ahead and solve this linear equation. Let's go ahead and distribute that negative. So 2 minus 1 plus 3m is equal to m plus 2. And I'm going to skip some math here, and feel free to pause the video and check my math if you need to. And I get 2m is equal to 1. And so I get m is equal to, oh goodness, 1/2. Okay, so now I'm going to make a number line just for us to see this stuff out. Okay, so let's put all my numbers of interest on a number line. So here's 2, and then I have 1/2. Oh, try that again. Let's erase that. Okay, and let's see. So if I have equality, that means I have a dot. Okay, and at 2 I also have a dot. Okay, great. And now I say that, let's see, I'll keep using black. So this condition's already met. This one, I say that, okay, it's less than or equal to 2, so that's this way. Okay, and now I have to look for their common parts. So what number or numbers do both of these conditions have in common? Well, that's going to be where they overlap, so that's just at this point. So the only value I have in the solution set is that 1/2. So I say the solution set for M is, and then if it's just a single point, that's when we represent it using curly braces. For M is 1/2 curly brace and period. There we go. Okay, so the idea with this is that if you're given conditions with your inequalities, to look at that conjunction, that and or. And you use an intersect, and then you look for the common parts. If you have an or, that's when you use a union, and then you just smush it all together and put it in one solution set. Okay, you may have to do a little bit of algebra with this stuff too. Okay, and that's the end of the video on inequalities with conditions.